Hello guys, hope you're doing great. So today I'm going to show the first part of this experiment, and as you can see we have such apparatus, and for that we need double walled aluminum calorimeter, this one, and inside we have resistant coil assembly. So let me show you how it looks like. So as you can see we have this resistant coil assembly, and we are also going to use the thermometer. And we have two multimeters, where one of them will serve as an ampermeter, the second one would be our voltmeter. So here in this part we are going to fill data table 2. For that, first we should set our ampermeter. As you know, ampermeter must be always connected in series, and we have the voltmeter which is connected in parallel. And we have also one more thing, the stopwatch. So the goal of this part is to see how the temperature changes over time. Okay, so let's get now started. Our power supply, we turn on our power supply, and we should set the ampermeter to 2 amps. Okay, and there we go. So here you can see the voltage across our resistance, and here you can see the temperature. So actually we started from 11 degrees Celsius, and we recorded or we measured how the temperature changed every 2 minutes. For that we started our stopwatch, and then we look at our value, the temperature value every 2 minutes. And also the important thing here is, in this table you must feel the temperature every 2 minutes, and then temperature difference. So temperature difference basically final temperature minus initial temperature. So obviously our initial would be 11 degrees Celsius, and here for example the temperature difference is 0.5, because I subtracted from 11.5 the initial temperature 11 degrees Celsius, which is 0.5 Celsius. So for till the end, as you can see, I subtracted the initial temperature, and so here you can see the temperature differences. So now we are going to show the second part of our experiment, where we are going to determine the temperature coefficient. In this part we are going to use this apparatus. So we have insulated cup, as you can see, and we have the thermometer, and we are also going to use coil wire, and we are going to determine how the resistance of this coil wire changes with temperature. And we are also going to use the ohm meter. So you should set to 200 ohms, because our expectation of this coil wire is small. And so our next step would be filling the data table 2. So here we start from filling data table 2, because we should determine the reference temperature. So for the reference temperature we took the room temperature as a 25 Celsius degree, and then the reference resistance. So as you can see here, initially we didn't feel any water, and in our reference it was 2.2 ohms, and now we are going to see how this. So as you can see, it's fluctuating between 2.2 and 2.3, so we took as 2.2, and now you will see how this resistance would change when we fill the boiled water. Okay, so we already boiled it, and we are going to pour into our resistance. So here, as you can see, the temperature increases, and also with temperature our resistance also increases, like 2.6. So actually when we use it at 95 degrees Celsius we read 2.8 ohms, and then we look at when the resistance drops to 2.7, we found the last temperature is 86 6.4 Celsius degree. So here this average is actually the average between this initial or first temperature and last temperature, and we found is 90.75. And here, for example, the last of these 2.8 would be the first of the 2.7, okay? And then when it dropped to 2.6, the temperature was 71.4. So now here the average of these two would be 78.9 Celsius degree. So after filling this table, you must make another table, data table 3. So as you can see, here we have data table 3. In the first column, you must fill with T average minus T reference. So as you remember, the T reference was 25 Celsius degrees, and T average here we determined the value. So 90.75 minus 25, it will be 65.75. And the second column would be RT or R reference. So as you remember, we took R reference as 2.2. So here we have these RT values, okay? So in our first row, you should just divide 2.2 by 2.8 by 2.2, and we found as 1.27. And next would be 1.23 and so forth.